You know. What is faster than speed of light? We are making progress at the speed of light. Soon we will have a destroyed planet in every drawing room, right next to our coffee table. I am saying this for a reason. What is the highest temperature you can imagine we have achieved by our fragile science on our planet? Make a guess. Starting from the beginning, the water boils at 100 degrees Celsius. Not a big deal. We can easily boil water in our little kitchens. Talking about something precious, pure gold melts down at 1064 degrees Celsius. I'm okay, this is also not a very big deal. Thinking out of the box, iron have a melting point of iron is 1538 degrees Celsius. World's most hardest substance, diamond, have a melting point of 3550 degrees Celsius. Now talking tungsten. It has a boiling point of more than 5500 degrees Celsius. Although this is wide range of temperature. But shockingly, boiling point of tungsten is negligible to the temperature we are going to discuss. Now I am going to ask you, what is the temperature of Sun's surface? It is 5600 degrees Celsius. But wait, don't start calling me a lunatic. Although this temperature is not much, but the core of Sun have a massive temperature of 15 million degrees Celsius. Wow! But why we are talking about it? Because, my friend, the temperature achieved by humans on Earth in labs is approximately 250,000 times hotter than the core of Sun. It is unbelievably 4 trillion degrees Celsius. Well guys, this is true. This temperature was achieved in a Large Hadron Collider at Brookhaven National Laboratory in New York State. This temperature was achieved when gold particles accelerated with nearly the speed of light together, causing the electrons and protons to melt down into a form of gluon and quark plasma. Although this was achieved for some milliseconds. But still, this temperature is significant because it was approximately the temperature shortly after the Big Bang. This collider is specifically used to model the universe in the first moments after the big explosion. Such modeling can help us understand how our universe was born and evolved, shedding light on its early stages of development. But this thing is a decade ago now. In many laboratories, scientists are generating a wide range of temperature. Our main question is, how? And why? It is clear they didn't generate this temperature using high octane or another type of fossil fuels. But how they can? Why the surrounding don't get melt down? A temperature which the more than the temperature of Sun's core. How our scientists are able to control it? There are a lot of fuels are powerful enough to burn down huge buildings when they gets ignite. Why these plasma just don't melt down everything? To understand this, first we have to understand what is bloody plasma. Plasma is the fourth and most abundant form of matter. 99% of our visible universe is made up of plasma. Plasma was first introduced by William Crookes in 1879 and named plasma Irving Langmuir in 1929. For the sake of easiness, you can define plasma as a superpositive charge and negative charge. Just like a liquid which is converted into a gas when heat is supplied. The gas, when extremely high energy is provided, converts into plasma. In space it occurs naturally. But we can also synthesize it in our labs. Now I hope your mind is clear with plasma. Because in next step I am going to explain a crucial point. Remember, I say plasma consists of charged particles. These charged particles easily and efficiently interact with magnetic fields. As we very well know, magnetic and electric fields are interrelated. So by the help of this we can create a cage by electromagnetic fields and can easily confine plasma in it, without allowing it touch the walls of container or any else.